I'm going to go through one more example of polynomial long division. There's one more important point I need to bring up. Now, if I'm going to carry out this quotient, please notice that I have a third degree, second degree, first degree, and constant in the numerator. But in the denominator, I've only got a second degree and a constant. I'm missing my first degree term. In a case like that, the best strategy is to include the first degree term with a coefficient of 0. The reason it's a good idea to include terms like this is when you carry out this algorithm, it's based on place value. And it turns out it's a lot easier to keep your place values correct. That is, third degree terms are working with each other and second degree terms are working with each other, because you can only subtract like terms. So when we carry out that subtraction step, we need to make sure that we have all of our third degree terms and second degree terms and first degree terms and constants right underneath each other so that we're subtracting like terms. So including a 0 every time you're missing a place value originally will really help at the end. Now I put my attention on the leftmost term and ask myself, what do I need to multiply x squared by to get x cubed? And the answer is x, and so that's what I'm going to put above the bar. Now I carry out the distribution. X times x squared is x cubed. X times 0x is 0x squared. And then I'll be subtracting 2x. I've just multiplied, multiplied, and multiplied. Now I need to subtract this new trinomial. So it's going to be negative x cubed minus 0x squared plus 2x. Because when you subtract this negative, it's going to be an addition. Now when I add, I'll get 0x cubes. I'll get 1x squared, and I won't have any x's. Now I bring down my constant, and I start the process again. I look at my first term. I look at my first term. I ask myself, what do I need to multiply x squared by to get x squared? The answer is, well, by 1. So I'm going to add 1 up above the bar here, and then distribute. 1 times x squared is x squared, 1 times 0x is 0x, and 1 times negative 2 is just negative 2. Now I'll subtract. This will be negative, subtraction, and addition. When I add these together, I get 0, I get 0, I get 0. My remainder's 0. That implies when you divide this polynomial by this polynomial, all you'll have is x plus 1. It also tells me that if I multiply x squared minus 2 times x plus 1, I'll get this as the product. And so this is a factor of my numerator. That's going to be important in your next class. Well, that's a second worked example with polynomial long division. In the next video, you'll have an opportunity to do a few.